controls the white line, that is the oxygen supply. Independent of the oxygen saturation levels, the oxygen supply will be increasing or decreasing depending on the working limits or in cases of critical conditions. To understand how it works, the oximeter, to acquire the signals, we started creating our oximeter basing of the functional of a real oximeter. After having that, we put our device can work in two ways: by simulations, putting the cases of lowering the oxygen saturation below 80% or operating, or with the real cases, with the data acquired by our oximeter.
We are from Saudi Arabia, King Abdulaziz University, and our project is wireless charger circuit design for pacemaker. Our SMART objectives are to devise a working prototype that wirelessly charge the battery of the pacemaker. Second, the recharging visit to be once a year, taking at most 3 hours to be fully charged. We test each part separately: the transmitter connecting with the function generator and the coil, the receiver, and the voltage indicator. We use an Arduino to just represent the charging process. This is our final product, a transmitter connected with the function generator that provide the voltage to the system and the safe frequency, connected with the receiver. Then we added a voltage regulator just to make sure that our product is charging with the suitable.
So my goal was to make a light portable device that would give patients air. So that's my final design. It's a really small box. It's real portable. Doctors can take it anywhere. And so it has 2 servo motors here and there. And basically they compress the back from both sides. You turn it on. And so as you can see now, I'm getting air. It is really simple. It has a main Arduino controller. It has a small motor driver. Code is simple. It's based off the idea of task scheduler. It's kind of how in a queue in a store.
We designed the robot to help those who go through stress in their daily lives, and our robot measures the user's stress levels by incorporating a heart monitoring technology, and it'll give different responses to the patient according to their heart rate. We use machine learning, which is a platform that allows us to record and train recognizing specific.
We used a heart monitor, which we soldered to the breadboard, to actually read the patient's heart rate and display it on the Arduino software port monitor.
So we combined machine learning with EV3 to enable the robot to give different responses to the patients according to their different heart.
It responds to the command high relax spot, and then it just moves towards the patient. So here, so if we go on the serial monitor and display it, it's gonna read off the red and then the IR values, which are the red LED and the infrared LED, and then it's just gonna read off our heart rate.
Hello, my name is Jonathan Bryant, and I'm the team leader of our group EcoTech Med, and today we are here to present our COVID-19 drone. This is an autonomous drone that utilizes viral agents to help detect COVID-19 in the air. The detection of the virus using this drone will help regulate safety in high-target areas such as communities of color, where the risk of contracting the virus is 2 times higher than in other areas of the United States.
Our string is one key press to start the code. Object is the drone, and anything afterwards is the function. And in the parentheses of each lies the value of each command, which means the direction or value of second.
And it has a couple built-in sensors. It has a gyroscope sensor, which helps keep the drone balanced, a IR height sensor, a barometer sensor, and a optical flow sensor for hovering. And this drone is programmable.
The goal overall is to make a viral map to be able to predict the next hotspot of the coronavirus. And our goal is to predict where the next place will be, alerting hospitals on what the next place should be. On the drone, there are these Q-tips with the blueberry solution, and we will be using that to indicate the color change of anything acidic in the air. Again, we're looking for a reddish tint to this color because the pH level of the coronavirus is 6.
We, the tech sisters, have developed 3 innovations to help restart normal life safely. The first is to help improve temperature. Someone with a normal body temperature comes before the screener. It will allow them to enter the building. When someone with a fever comes before the screener, the PIR sensor will detect movement, the thermal imaging camera will take a thermal scan, and will alert them to return home and seek medical attention.
You have a high body temperature. Please go home and consult a doctor.
We use Python to program this on a Raspberry Pi. The next innovation is to help improve facial protection. We have built the protection helmet. The helmet has a fan at the top to create positive air pressure. This will only allow filtered air to come in through the top while not allowing any unfiltered air to be breathed in. The helmet also acts as a social distancing monitor with ultrasonic sensors at the front and back to measure distance. Our third and final innovation is simple, inexpensive, non-invasive ventilator. The inhalation cylinder will draw in fresh air and then provide it to the patient. The exhalation cylinder will extract the exhaled air and push it through hot water kept at above 56 degrees centigrade to disinfect.
The Robo represents the bed or the gurney or wheelchair that will be used to transport the patient. The demo area represents the hospital, and each room in the hospital is designated by a different color. A mobility system, a robotic arm, and connection to the cloud. We're scanning the rooms to create an internal map. Look at the top of the image. This shows how we process the images. We convert to grayscale, blur, detect contours, and detect the different circles in the image to detect which rooms are there. We determine the room based on the color. We know the angle based on the screen coordinates and calculate the distance based on the circle stats. Notice when Maria moves the board that the position and angles are getting automatically updated. Self-driving automatically isolates patients and prevents transmissions of diseases like COVID-19. We send commands to 6 servos to perform this operation. It will have a camera connected, and it will change tools for every job.
Our event aims to help blind people adapt the environment for walking on the street and find their destination safely and easily.
The way it works is that a receiver will be installed at the tips of the blind person's sticks. Detecting nearby beacons. The beacons will be located around on the street, on the floor, Okay, as you can see. If I put away my phone, the alarm stops. If I put my phone near it, it will turn. Yeah. The turn left signal is determined by the destination set by the users. Yeah, it's like a Google Map function. Yeah, it guides you to your destination and just overall easier to be used by blind people.
Robot for people in isolation, which can perform that routine without the need for a professional. Distribution of pills is simulating a vending machine with capacity for 3 different pills and serum and water. Each patient has given an e-refilling card, and this specifies the medicine at mealtime as well.
1. Connecting the application via Bluetooth. The Android application was developed in Java with Android Studio IDE, and the Windows application was developed in Python using the libraries Serial, Tkinter, and Seculate3. Second form, NICTE was programmed as a line follower capable of identifying patterns on the floor for the activities of the robot. The structure consists in a metal structure for the base, MDF structure for the body and head, mechanical components, bands, gears, and electronic components, motors and pumps. This is the Android application.
I take food.
Thank you so much for your participation in today's RoboMed competition. All the projects were very creative and innovative.